Hi students, my dear NEET aspirants, IIT aspirants, CBSE students all over India. Welcome to Bhanu moorthy's Academy of Objective Physics. This is a conceptual orientation coaching for NEET as well as IIT. Now, last week, so many requests came from the students and parents all over India. They're requesting me that please explain or give the information regarding electromagnetism, the orientation of magnetic lines of force around a current carrying conductor. So, then for the sake of students, I thought seriously and trying to give the information as maximum as possible about magnetic lines to the students for entrance 2024 NEET entrance. So my dear students, let us discuss this brief topic regarding magnetic lines orientation around current carrying conductor. Now let us see this first case. In different situations we are discussing. This is the first situation. This is a straight conductor through which current is carrying upward direction. You please remember two rules. One is right hand thumb rule and the one is screw rule. Okay, if you know these two rules, you can identify the direction of magnetic lines of force. So this is the first case. Current is moving upward direction along a vertical conductor. Then if the thumb represents direction of magnetic fields, direction of current, and remaining four fingers represent the direction of magnetic field. So these are magnetic lines of force, remaining four fingers. Okay, so in this case thumb represents current direction, remaining four fingers are representing direction of magnetic field. So this is nothing but magnetic lines of force, anti-clockwise direction. Okay, current is up, magnetic lines are anti-clockwise. Remember this one. And one more sentence is, right side of this wire, that is due east, the magnetic lines are into the paper. So magnetic lines are into the paper. You see, this is the direction, magnetic lines are into the paper. That's why it is represented by star. Okay, star represents B into the paper. This is the board page. This is into. Okay, and in left side of this conductor, that is due west, magnetic lines are going away, outside of the page. Okay, this is outside of the page. In the second situation, if the current is flowing downward direction, like this is the thumb rule. Current direction is thumb. Remaining four fingers represent direction of magnetic field. Here the fingers represent into the paper towards west and towards east out of the paper. You see, out of the paper. Towards west out of the paper and towards east into the paper. Okay, this is representation, and here this is clockwise orientation. Okay, this is anti-clockwise, and this is clockwise. Okay, this is the representation. Next case is in the case of a horizontal wire, current is going towards east. So if the current is going towards east, so the screw drive, this is a screw rule. If the screw is rotated in this direction, so in anti-clockwise direction, screw is coming towards east. So the motion of the screw represents direction of current, and motion of the rotation of the screw represents what is that? Magnetic lines of force. So if the current moves in east direction, magnetic lines of force anti-clockwise. Okay. Next, above this wire, the magnetic induction is out of the page, because you see this one, the current direction is thumb rule. This is thumb rule, and remaining four fingers above this wire are out of the paper. Okay, and at the same time, these fingers are into the paper. So current direction into the paper. Current direction into the paper, out of the paper. See here, this is out of the paper and this is into the paper. Okay. Next, let us go to this point. If the current moves west side, okay, so the direction of is a clockwise orientation, because here the conductor is moving towards the right. So the direction of orientation of the screw is clockwise. Okay, the screw moves up. Direction of motion represents current. Direction of rotation of the screw represents magnetic field. So this is clockwise. And above this wire, the field is, suppose you see, this is the thumb and four fingers are into the paper. Okay, so like this into the paper. So this is star, and below this out of the paper. Okay, so below this wire field direction is out of the paper, out of the page, and above this into the page. My dear students, this is the information we are discussing here in tips number 4. Okay, in this video class, tips number 3, I have given this information to you. One more information I want to give to you, that is, this is a current carrying conductor. Okay, I am going to type this. This is the circle. At point A, I want magnetic induction. At point A, magnetic induction is towards north. So this is due east. Due east of this conductor, magnetic field direction is towards north. And due north of the conductor, this is due north. Due north of the conductor, magnetic field direction is towards west. Due west of the conductor, due west of this conductor, direction of magnetic field is south. That is B. And due south of the conductor, okay, magnetic field here is due east. So because magnetic field orientation is anti-clockwise, no, everywhere. So due east north, due west, due north west, due west north south, due south it is towards east. And what about magnetic induction? Earth's magnetic field. Earth's magnetic field always represents points towards north. So here towards north BH, here towards north BH. BH means Earth's magnetic field. Here BH and here also BH. So everywhere horizontal component of Earth's magnetic field is pointing towards north. Okay. So now, my dear students, you observe at which point magnetic induction is maximum. So here it is maximum because both are in the same direction. Here it is minimum because both are in opposite direction. B minus BH. But here only BH is there because B is 0. Here also B is 0. Why? Because on the wire, at every point on the wire, magnetic induction is 0. You have to remember this point. At every point along the conductor or on the conductor, magnetic induction B equal to 0 according to Biot-Savart law, because sin 0 equal to 0. Okay, so on the point, on the line, magnetic induction 0. Then, but it has some vector. So it has some direction. It's a null vector there. So B is null vector at this point and at this point. Okay, so my dear students, here only BH, here only BH, but here maximum B plus BH, here minimum B minus BH. So this is a representation of direction of orientation of magnetic field and magnitude of net magnetic field around a current carrying conductor. So this is the way of explanation in this academy, Bhanu moorthy's Academy of Objective Physics. It is situated in Vanasthalipuram as well as Nagol, Jarasta, Bandlagud, towards Bandlagud crossroad. Okay, so if you want to join in this institution, you contact to these numbers and we will give entire information to you regarding classes. These are tuition classes, only physics classes. Okay, so in the early morning hours and in the evening hours, we are conducting the classes. Okay, for details you contact here. If you are interested, like, share and subscribe. Please don't forget to press the bell button and do viral this information to all your friend circle so that everybody can gain the benefit for entrance examination 2024. So this is the maximum information I have given regarding directions of magnetic field. I hope everybody can get the benefit. Thank you. So in the next video class, in tips number 4, I am going to explain some more important topics depending upon parents and students' request. Okay, bye.